Hello again, I'm Leon from Sourcefire Security Engineering Group in the UK, and today's quick tip is how to add customer service detection into your RNA network monitoring infrastructure. So at the core of RNA is a real-time protocol decoder that works right up the stack to associate service information with port numbers, because you know just as well as I do that TCP port 80 doesn't always mean HTTP in the same way as HTTP doesn't always mean TCP 80. From a user's perspective, this has a couple of advantages. It provides the obvious IPS event correlation against target service you'd expect it to, but along with it comes some other things like automated tuning help. For example, did you know that old printer over there is actually running an old out-of-date version of Apache which is vulnerable on some obscure high management port? And because of that, would you like to automatically enable the correct IPS detection and prevention controls to protect that service? There are some other less obvious advantages with this service detection, such as data leakage protection and also real-time policy compliance monitoring, but those are points for another day. RNA comes pre-built with a wide list of protocol decoders which match most of the needs of the enterprise and also internet community, but if you're running something custom in-house, it's possible you might want to add your own custom decoder. So that's what I'm going to give you a demonstration of how to do today. To add a custom RNA protocol decoder that will detect a Windows XP bind shell regardless of what port it is discovered on. So here I'm looking at a table view of security events that have been detected on my network over a certain time period. I can see that at 8:57 and 57 seconds an event occurred which is a high priority and a red impact flag. Now that's a bit of a magic combination within Sourcefire 3D system, because that kind of gets my attention to say this is an event that needs some analysis right now, because this event could cause me a large amount of pain and is also quite likely to have caused that amount of pain. The destination of this attack was 192.168.1.125, and the type of attack was actually a NetBIOS DC RPC buffer overflow. But rather than drilling down into a packet view and doing some traditional event analysis against this event, what I'm going to do is pivot my view of this information of what's occurred on my network away from security events into change and discovery events. And I'm going to do this by clicking on the RNA Events tab. So this is a view of all changes that occurred around the time of the attack. And I can see at 8:57 and 57 seconds, a new TCP service was detected on the targeted device and on port 4444. So something changed following this attack, and now that's interesting. So if I click on the context icon next to the IP address, I'll see the full host details for this IP address. So this is the host record associated with 192.168.10.125, a device with a host name called Wintermute. It's a Windows XP system running some common Windows services, but there's something interesting here down the bottom, TCP port 4444, where we noticed our new service startup. By clicking on the view link here, it will give us a detailed view of what this service is, how many times it's been accessed, and it will also show us the banner of this service. So this is a banner which probably stands out a mile for anyone watching this, because it looks like a Windows XP bind shell, which means there's a command interpreter bound to a TCP port, in this example of 4444, which will allow any remote user to open up a telnet session and get access to this device. So let's use this information of its service banner to create our custom protocol decoder. So if I browse to my defense-centered user interface, I can navigate to Policy and Response, RNA, Custom Service Detectors, to get a list of all custom service detectors on my system. All custom service detectors are grouped so they are easy to export and share between different defense centers. So I'm going to add a new detector to my TCP services group. I simply give the custom service a name. In this example, I'm going to call it XP Command Shell, because this is a remote command shell on Windows XP. I am going to match against the protocol TCP rather than UDP. But I could type in a port constraint here. However, because the bad guys could be binding shells to any port, I don't necessarily want to constrain my search just to TCP port 4444. I want to associate this service with content that's found within the data stream rather than metadata like a TCP port. So to do this, I'm going to take another look at my banner of this service, which I can see is Microsoft Windows XP version 5, and I'm going to take this information and copy it and paste it into a pattern match. So to add that to a pattern match, I click Add Pattern. I can choose whether I want to match in the ASCII decoded portion of the packet or in raw hex. I type in my pattern string, which is Windows XP version 5.1. I can specify where in the packet I want to look by using an offset. And this is similar to Snort's content offset and depth rules. So if we're using an offset of 0, it will start matching right from the start of this packet. If I optionally add a PCAP and browse to it, this would allow the Defense Center to actually run a test PCAP through this service match criteria and pattern match criteria I've configured on Defense Center and tell me if I get a match. So if I click the Evaluate button, fingers crossed, we'll get our custom service detected. So all I have to do now is click Save on this service. And then remember to click the Activate button in my Custom Service Detector list. And then all Windows XP command shells should be detected as long as they present the same banner as I've placed in my Custom Service Detector. Okay, so in classic web demonstration style, here's one I made earlier. So if I now change my view to another Defense Center, which has had the same data run past it, and my Windows XP command shell custom detection enabled, I can see if I drill down through this service list, I will discover a host 192.168.10.125, which is good old Wintermute. And drilling down through my service list, I can see on TCP port 4444 we have our XP command shell. So, as you can see, it's pretty easy to make your own custom RNA protocol decoders. A quick word of advice: it's always best to test these types of functions in a lab before you roll them out into your production network. Just like writing a snort rule, you want to make sure it works and does what you think it's going to do before you actually run with it. If you'd like to take a look at the data set that I was running through my Defense Center, 3D sensor and intrusion sensor there, you're welcome to download the PCAP files. They're available on openpacket.org, but due to OpenPacket's upload limits, there's a couple in the data set missing. Most of the ones we actually have the attack data in. You can find those on my blog at rm-rf.co.uk or leonward.wordpress.com. And if you have any questions, throw me an email at the normal email address. Thank you very much, and I hope this session has been of use. Bye-bye.